Okay, there's still two people who are not here. I'm not sure who are those two. You were 9, so now two people are not here. Okay, right, but anyway, we'll continue. So we move on. Question number 3. In the circuit diagram below, the reading on voltmeter V1 is 12 volts, all right? It's 12 volts, and the reading on ammeter A1 is 2 amperes, all right? So that's your across the battery, all right? So this is supposed to be V1 here. So there's a V1 missing here. That's your 12 volts. All right, then you've got your current 2 amperes. That's the information that you're given. Right, then you've got your 6 ohm resistor, 3 ohm resistor in parallel, and you've got a 4 ohm resistor in series with these two that are in parallel. Right, then we move on to the next one, 3.1. Calculate the total resistance of the circuit. So total resistance of the circuit, you must add all the resistors that are here. So you're not just going to say 4 plus 6, so 4 plus 6 plus 3. So, you know, your answer is not 13 here. You need to be careful. So you're going to start by adding the resistors that are in parallel first because they've got a different way of adding them. All right, so you're going to say 1 over R1 plus 1 over R2, which is 1 over 6 plus 1 over 3. Then you flip your answer. All right, okay, all right. So your answer is supposed to look like this for 3.1.1. You're going to add the parallel first. So it's 1 over R1 plus 1 over R2, all right, which is 1 over 6 plus 1 over 3, all right. Then your answer, if you do this on the calculator, you're not going to get 2 straight away. There's a flipping that took place here, all right, because 1 over 6 plus 1 over a third, that's going to be, you got your, you're going to get your LCD 6. 6 into 6 goes once. Should I do that? Do you understand this, guys?
Yes, sir.
Should I do it or you understand it?
Oh, I understand.
Huh? You
No.
So you
understand how
can
we
do
get?
it.
I can do it. Okay. All right. For you to understand how we get the 2. Okay. So basically, you got your 1 over 6 plus 1 over 3. So your LCD is going to be 6. 6 into 6 goes once, times 1, you get a 1. 3 into 6 goes twice, 2 times 1, you get a 2. 1 plus 2 gives you 3 over 6. Then you flip this. You need to flip this. So you're going to flip these two numbers here. So that will give you 6 over 3. And 6 over 3 is the equal to 2. That's where the 2 is coming from. That's where you get the 2 ohms. Right. Okay. We move on. All right. So you get your 2 ohms. After you get your 2 ohms, you're not done because we need the total. So you're going to go back. So the 2 is just for these two here, the 3 and the 6. Now you need to add the 4. So many people would forget to add the 4. So you're going to take 2 plus 4 now. That will give you the total because there are only 3 resistors here. It will be 2, the total for 6 and 3, plus the 4. That's what you're going to get here. Clear? Right. So you get your 6 ohms. Right. Yes, Joshua. Joshua. You use the total resistance. You use the, okay. The other way to do it, because you've got 12 total, what are we looking for here? We are looking for the total resistance. Okay. Another way that Joshua is showing there, you can, because you've got total current and you've got total voltage, all right? You can simply use 12 divided by 2, which is R is equal to I. Let me just show you here what is trying to say here. Okay. What he's trying to say is this. I will just write it here on this corner here. Just saying you can use the formula R is equal to V over I. So R must be total. If you want to get total resistance, you must use total voltage, and you must use total current. So your total voltage is given as 12, and your current is given as 2. So you can simply say 12 divided by 2 to give you 6 ohms. You can also do that one. It's still fine. You still get 6. You still get a 6 here, because here you still have to add your 2 plus your 4 to give you your 6 ohms. So there are two ways of doing this, right? Like, because here it will work because we are given total voltage and you're given total current. But please be careful with the current and the voltage. You need to know, how do you know it's total voltage? Is the voltage that is across the battery. How do you know it's total current? Your total current must be the connection from the battery, that single connection, no splitting must be there. If the ammeter is on that place, then it measures total current, then it will work out, right? Okay, that's what we have on that one. Two options for you to get the answer, right? So total resistance, let me just check again on the solutions here. 3.1, so you can also do that. Here they didn't use R is equal to, because in grade 10 and 11, that Ohm's law equation, R is equal to V over I, they try to discourage it because we haven't done Ohm's law. That's why you see on the options, that option suggested by Joshua is not here, but it will work out, provided you understand how to use it, it's fine. Right, then we'll move on to the next one. The reading on V2, reading on V2, right? So V2, there is V2, all right? What are you gonna do here? On V2, what do we have? We've got the current. If this one is 2 amperes, it means also here we've got 2 amperes here, all right? Because this is measuring total, because it's a single wire to the battery, single wire to the battery. So to give us the total current, which is 2 amperes. So we know two things about this 4 ohm resistor. We know its resistance and we know its current. So using the formula, let me just check how they did it on the solution. Yeah, like here, they've used the same. R is equal to V over I, all right? So the resistance, we know it's 4. The voltage, that's what you're looking for V2. Total current, we know it's 2. Then you make your V2 the subject. So you're gonna cross multiply. 4 times 2 gives you 8 volts. So the voltage across V2 is 8 volts. So you're gonna get your 8 volts here. Clear?
Yes.
Right. If you don't want to do this, you can also use ratios. Let me just show you the ratio. You can also use ratios here. Let me do a screenshot here. Okay. I just want to do a screenshot quickly. Okay, then let me open this. Right, so basically, what you're going to do, if you want to use ratios, okay, let me just delete this. Okay, right, so if you want to use ratios, it can work as well. So what are you going to say? You know the total resistance here. We got the total resistance here. We said the answer was it was 2 here, right? So the resistance parallel ratio is to the other resistor that is in series. The ratio here we know it's 2 is to 4. All right. Then what else do we know here? We know these two are supposed to share the 12 volts equally. Sorry, not equally, proportionally. So it's like you've got a piece of cake that's the size is 12 volts. You want to know how many units will each one get? They must share in the ratio 2 is to 4. So what are you gonna say? You're gonna say 2 plus 4, which gives 6. So 6 is the total over. We want to know the resistance. I want to know the voltage across the 4. So we're gonna say 4 over 6. Where did I get the 6? I added the 2 ratios, 2 plus 4, to give me 6. Why am I taking 4? Because I want to know the voltage that is flowing in the 4 ohm. So if I wanted the one that is flowing in the parallel, I was going to take 2. So here I'm going to take the 4. Multiply by, they have to share. proportionally the 12 volts. So I'm going to use that. Then my answer, 6 into 6 goes once, into 12 it goes 2 times. 2 times 4 gives you 8 volts. So you can use a ratio as well to get your volts, 8 volts. So you can also get this by using ratios. So it will also work. Right, okay. Is that a question? No. Okay, we'll move on to the next one. The reading on A2, reading on A2. So here's A2. So for A2, what do we know? We know the, what do we know here? We know the resistance here, all right? And what else do we know? I think that's all we know, all right? But we know the 2 ohm, the 2 amperes, when it gets here, it's gonna be split proportionally. So there are a couple of ways for you to get the answer. You can use proportion here to calculate the answer, all right? But the proportion that you're going to use is going to be different with the voltage because the current and resistance, they are inversely proportional. But I'll show you how you do that one. So the easiest way would be for you to get the voltage that is flowing across the parallel. So we know this one is taking 12 and this one is taking 4. Let me just show you. I think I've got that picture here so that I show you what I'm trying to say here on the picture. All right. What I'm trying to say is this. Right. The voltage here, 12, all right, it's split into 2. This one gets 8 volts, right? And here, if I put a voltmeter here across here, if I put a voltmeter here across here, right, that will be the voltage across the parallel here, right? So now, if this one is taking 8, I know the total must be 12. So it means the voltage that is flowing here is 4 volts. It's 4 volts because 4 plus 8 must give me the total across the battery, across V1 here. I must get 12 volts, right? So here, what do I know about the 6 ohm? The 6 ohm, I know the voltage, I know the resistance, so I can get the current. So I can just use the formula I, current is equal to, I've got R is equal to V over I, then therefore it means I is gonna be R over V, am I right here? V is equal to IR. Therefore my R is gonna be V over R, not R over V. You must be careful with the equation here. So it's gonna be V over R. Right, so I'm going to take the voltage. The voltage is 4. Divide by the total resistance. What is the resistance that I have here? The resistance is 6. All right, then I'm going to get my answer. All right, my answer is going to be 0.6 something. 4 divided by 6. I got 0.67. So I'm going to get 0.6. Sorry about that. 67 amperes. That would be the current that is flowing in the A2, right? That's how you get it, right? Another way for you to do it, is this. You can use ratios. If you want, you can use ratios. How do you use ratios? You can use 6:3, right? And they're sharing 2 amperes. They're sharing 2 amperes. Right, so I'm going to add 3 plus 6 gives me 9. Right, then what do I know? I know the one that is a bigger resistance will get less current, and the one that has got a smaller resistance gets more current. So I'm going to swap the two. Why am I swapping? Because I need the one. I need to get the voltage that is flowing in the 6 ohm. It will get less current. So if I say 6 over 9, that fraction becomes bigger. So I'll say 3 over 9 multiplied by 2 over 1. But you need to be careful with this method because you need to understand why am I switching here. So it's going to be a third of 2. So it's going to be 2 times 3 divided by 9. My answer is also 0.67. So when you use this, you must be careful here. Because if you're going to use 6, because we want to know the current that is flowing in the 6. If you're going to say 6/9, you are giving it more current, yet it has got more resistance. So this becomes incorrect because your answer is going to be bigger. The bigger answer is for the smaller resistor. So here you must be careful here when you take this method here. Right, this becomes incorrect here. Why? Because you are giving it a bigger share of current, yet the higher the resistance, the smaller the current. Clear?
Yes.
Right, okay, we move on. Next one. All right, reading on A2, we've done that. Amount of charge that flows through ammeter A1 in 120 seconds. All right? Right? We need the amount of charge that flows through ammeter A1 in 120 seconds. We want the amount of charge that flows in ammeter A1, 120 seconds. Right, so let's look at A1. A1 is 2 amperes. So you can do your data here. Your data, you've got time, all right? Amount of charge. So we're looking for Q. And you've got, well, let's look at A1. A1, that's an ammeter, so we know it's current and we know time. So you go to your equation. Just share this so that you see it. Where is this? Okay, there we go. Okay, so basically what you have here, you've got your current. Your current is 2 amperes. And we are looking for charge. We're looking for charge, and we are given time. Time is equal to 120 seconds. So we're going to say Q is equal to I times T. All right, which is going to give us your 2 amperes multiplied by your 120. Therefore, your answer becomes 240. Right, so you've got your 240 coulombs here. You're going to get your 240 coulombs. Clear?
Yes.
Right, okay. All right, so that's what you have for that particular one. Right, then we move on. Let me just show you here. Okay, so basically this is what you do here. You've got your charge, you've got your current, then you've got your time. Then you're gonna multiply the 2, then you get that. Clear? All right, then we'll move on to the next one. The next one says 3.2. How will the reading on ammeter A1 be affected if the 6 ohm resistor is removed from the circuit? How will the reading on the ammeter A1 be affected if the 6 ohm resistor is removed from the circuit? Write down increases, decreases, or remain the same. What do you say here? We are removing this 6. What do you say? What is going to happen?
There will be more current
There will be more current.
flowing to A2.
More current flowing to A2. But A2 is no longer there because we are removing it. So A2 is also going with the 6 ohm.
So 6 ohms goes with A2 as well.
Yeah, basically, okay, let me see here. How will the reading on A1 be affected if 6 ohm resistor is removed from? Yeah, so we are removing this whole channel. We are taking it with A2. We are removing
I
it.
don't think. I think it will remain the same.
It will remain the same.
That's what I think. So.
Okay. All right. Joshua, what do you say? You say decrease. It will decrease. Okay. Why does it decrease, Joshua? Joshua, you're not talking today. What's wrong? Is your speaker a problem? You're only sending messages here. Okay. Let me see. Let me explain to you from here. This one is okay. Let me take another screenshot here. Okay. Resume share. Let me take another screenshot. Okay, just a second. Right. So basically, this is what you have. Okay, let me see. Okay. So basically, what we're gonna do is this. We're gonna take off this. We are removing this. We don't have this. So it means current when it flows, it's only gonna flow like this. Flows this way. Gets here. Goes like this. It goes like this. When it gets here, passes here, and goes that way. Right. So if we remove this, what do you see? It means we are taking out the parallel connection. When you take out the parallel connection here, what is our total resistance here? Our total resistance becomes, our total resistance is now 3 plus 4. Is 3 plus 4, which gives you 7 ohms. What was our total before? Our total, our total before, right? Before, right, it was equal to, I think we got 2 plus 4, which was equal to 6 ohms. So by removing the 6 ohm resistor, what are we doing to our total resistance? Our total resistance increases. And what do we know? What is the relationship here? Resistance and current, they are inversely proportional. Sorry, here. Resistance and current, they are inversely proportional. The bigger the resistance, the smaller the current. Clear? So our resistance is increased, therefore our current is going to decrease. So it means the reading here, it won't be 2, it will be less than 2. So the current will decrease here. Is that clear, Zinedine?
Okay, sir.
Yes. So you must check the connection first, right? For example, if we remove the 4 ohm, so it means we're going to have only the ones in parallel, and their total will only be 2. So it means the resistance is decreased. If the resistance decreases, therefore it means current must increase. So if I'm going to remove the 4, it means I'm going to reduce the total resistance from 6 to 2, because I only have those 2 in parallel. So that's what you must check. What effect does it have on the total resistance? Then you check now the relationship between resistance and current. Is that clear? Zinedine?
Yes, sir.
Okay. All right. Anyone else with a question here in Tokozo? Do you understand that?
Yes, sir, I do.
Okay. All right. Then we move on. Jolisha also, and who else here? Owen. I hope you understand there. And Sunny. Okay. Right. Fine. Let's move on to the next one. Right. So we are done with this. We are done with this one. Explain the answer to question 11.2. Okay, that was supposed to be 3.2 without any calculations. Explain that. Right. So what are you gonna say? Let's look to make it short. If the 6 ohm resistor is removed, the resistance of the whole circuit increases. Right. If you remove the 6 ohm resistor, the parallel and the series, you no longer have parallel and series. You just have series. So it will have an effect of increasing the total resistance. So the resistance of the whole circuit increases. Right, since resistance is inversely proportional to current, if resistance increases, V is constant, and the current of the circuit decreases. So that would be your answer there. Clear? I'll post these solutions here for you on Google Classroom. Then you can use that. Right. So we are done with the number 3. Let's move on to number 4. I'm not sure how much time we have left. Okay. So let's look at number 4. Study the circuit diagram below. Ignore the resistance of the battery and the wires. So you have your V across the battery. You've got your ammeter for total current. You've got the unknown resistor here. You've got a switch in the parallel circuit. You've got your 4 ohm. You've got another 4 ohm there. They're in parallel. Then you've got your V2 there, measuring the voltage across only the 4 ohm here. Right. When switch S1 is open, the voltmeter V1 has a reading. Right. So when you close S1, voltmeter V1 has a reading, right? So V1 is the one across the battery. So this one won't have a, let me see. This one will still have a reading here. Okay, but it's fine. What is the term used to describe this reading on V1? On V1, what do you say? What is it? Joshua, you say EMF, electromotive force. Joshua says electromotive force. Is it correct? Is it correct here? Let me check here. EMF. But actually, this answer is wrong here. It's not EMF here.
What is it?
Huh?
Then what is it if it's not EMF?
It's supposed to be terminal potential difference.
Yeah.
It's supposed to be terminal potential difference. Yes. Okay. Right. Check here. Let me show you here why this answer is wrong here. Let me just quickly take a snapshot of this. Let me explain this. Quickly. Actually, this answer is incorrect here. We need to check. For you to say electromotive force, you need to check the following. Right. If I close this switch here, if I close that switch, let's look at the current. The current is going to flow like this. It's going to flow this way. It gets here. When it gets here, current is not going to go in this channel here because there's an open switch here. Current is going to go like this. It's going to flow in this channel here. And when it gets here, it's going to go this way. All right, it can't go that way because there's an open switch there. So if we move that way, then we go back. So actually this scenario here is a bit different. Why? Because there are two switches here. This switch here is closing for this outer circuit here. So that current can flow like this and go like that way. All right. So it's not going to be terminal potential difference. Why? Because current is going to flow here in the outer circuit here, not in this branch because of that open switch. So actually here the answer is not EMF. Answer is supposed to be terminal potential difference, or you can just say potential difference, it's fine. It's not terminal because you still have to close that. Clear?
Yes.
Yes. What is making it different is because when we close this switch, actually current is able to flow because there's a complete circuit here in this channel here. It goes like this and it goes back to the battery. But the only difference is that it's not going to go in this channel because there's an open switch here. Right. So let me check if I understood this question correctly here. You say when switch 1 is open. Okay. All right. So here it's not closed. So it's fine. They said when switch S1 is open, the voltmeter V1 is a reading. Okay. Then it's fine to be EMF. So I'm wrong here. I thought they are closing S1. So S1 is still open. So it's fine. So here we still have an open switch, open switch. So if this is open, open, then that one will be EMF. So, okay, that one is correct. I'm wrong here. Okay, next one. Both switches are now closed. the total resistance of the circuit becomes 4 ohms. Right? The total resistance of the circuit becomes 4 ohms. Right? The total resistance is 4 ohms. So if it means if we add this in parallel plus the unknown resistor, the total is 4. So they say calculate, okay, both switches, the total is 4. Define 1 ohm. Define 1 ohm. Right? 1 ohm, it's 1 volt per ampere. Where do we get this? Where do we get this? Okay. Resume share. Okay. Where do we get this? We get it from this formula here. R is equal to V over I. And we know the units for voltage, it's 1 volt. And units for current, 1 ampere. So this gives us 1 ohm. Give us 1 ohm. So 1 ohm is equal to 1 volt per ampere. That's the definition for 1 ohm. Okay, we'll move on to the next one. Okay, move on to this. Right, the next one. It says calculate the value for R for 5 marks. Value for R for 5 marks. So what are you going to do? You know the total resistance here. So what are you going to say? You need to add these two that are in parallel first. Then when you add plus R, the total must be 4. So that one is not a difficult one. It's going to be, let me just do this quickly. Basically what we're saying is this. We're saying you start with your parallel. So it's going to be 1 over 4 plus 1 over 4 because the ones that are in parallel were given. 1 over 4 plus 1 over 4 gives us 2 over 4. Right? We're going to flip this. When you flip this, it becomes 4 over 2. It becomes 4 over 2. 4 over 2 is going to give you 2 ohms. But what we know, we are told that the total resistance there, R total, is 4. So we know R total is given by R parallel plus R series. So R total, we're told it's 4. And R parallel, we found it to be 2 plus R series. So we can get our R series. So R series, we're going to subtract. R series is equal to 4 minus 2. So it means that resistor, non-resistor is 2 ohms. That's what you get. Clear? Right. We move on to the next one. Let's just double check what we have here. So the same applies here. They've done the same way. 1 over 4, you get your 2, you subtract, then you get your 2. Right, then we move on to the next one. Calculate the reading on the ammeter if 180 coulombs of charge passes through each of the 4 ohm resistor in 2 minutes. Calculate the reading on the ammeter if 180 coulombs of charge pass through each of. So here, what are you given here? You have resistance, you've got time, you've got coulombs, right? We're looking, calculate the reading on the ammeter if 180 coulombs of charge pass through each of the resistor in 2 minutes, right? So basically you are calculating current, but using the formula Q is equal to IT. So you're going to use the following. Q is equal to I times T. Charge, you have 180. You're looking for I, and your time is 2 minutes. 2 minutes, you have to convert it to seconds. It's 2 by 60, gives you 120. 120, you divide both sides, then your answer becomes 1.5 amperes. That's how you get that one. Right? Then they say the ammeter. Okay, let's just check again this question here. They say calculate the reading on the ammeter. Where is the ammeter? Our ammeter is measuring total. So the answer that we got is only for one channel here. There are 2 channels because we know current splits here. Right? So you need to be aware where the ammeter is lying. What is it measuring? It's measuring total current. It's not measuring partial current. So you have to add. Each one will get the answer that we got from there. The answer there was 1.5. So each ammeter, each 4 ohm resistor is going to have 1,5 and this one 1,5. But we know when it gets here, it adds. When it was here, it split into 2. So the total here is going to be 1,5 times 2, which gives you 3. So your answer becomes 3 amperes. That's how you get that one. So don't forget to multiply the 2. Otherwise, you will get only for each 4 ohm resistor. Next one, we've got 3 minutes, 30 seconds. We have 1080 joules of energy is needed to move 180 coulomb charge across one 4 ohm resistor. Calculate the reading on V2. We go again and check V2. Where is our V2? Our V2 is across one single 4 ohm. So we're only going to work out with 1 4 ohm. Right? So what are we going to say? Work divide by charge. So work, we are given 1080 and charge is 180. So we divide that, then we get 6 volts. So they're asking questions here in a different way using the definitions formula, right? V is equal to W over Q here. So that's how you get that one. So please do your data so that it becomes easy for you to identify which equation to use. Then we move on to the next one. Without doing any calculation, a calculation involving a formula, determine the reading on V1, explain how you arrive at your answer. So wait, let's go to V1. There's your V1 there, right? So your V1, how do we get V1? We know this is 6. R, the voltage across R, we don't have that, right? But we have got, we now know it's a resistance and we know the current. But say without doing a calculation involving a formula, determine the reading on V1, explain how you arrived at your answer. Let's check here. V1 is equal to 12 volts. Resistance of R is equal to the resistance of the parallel branch. And the other one, VR, is equal to V parallel, right? 6 volts. So therefore, you add the 2 to get 12 volts. Do you understand that explanation there? Do you get it? Okay, basically what we are saying here, the resistance, we know the resistance here. Let's check the resistance that we got for R. R is 2 ohms, right? So basically we know when you add 1 over 4 plus 1 over 4, it gives you 2 over 4. When you flip it, it gives you 2. Actually, the resistance in the parallel and in the series, they are the same. It's 2, 2. Because when you add 1 over 4 plus 1 over 4, it gives us 2 when you flip. So this one is 2. This one is 2. They've got the same resistance. So it means if this one is 6, it means this one is also 6 because they've got the same resistance. So therefore, 6 plus 6 gives us 12. That's where the 12 is coming from. Is that clear? Right, I'll post the answers for you, then you will double check. I think I'll stop here. We've got maybe 30 seconds left. I'll just explain this maybe on Monday, first thing before we move on to the next lesson. So I'll stop here. Any questions? Hello, any questions? Guys, any questions? Right, if there are no questions, let's meet on Monday at 2 o'clock. Is it fine?
Yes, sir.
Yes.
Okay, let's meet on Monday. Thank you. Enjoy the rest of your weekend. Bye.
You too.
Okay, bye.
Bye.
Bye.